Gas metal arc welding, gun and wire feed troubleshooting. Gary A. Pace, PE, welding engineer, Katy, Texas. So this is our wire. This is how our electrode comes. As I've said before, it's covered in copper because copper doesn't rust and it keeps our steel filler material, our electrode from rusting. If our filler material rusts, we're going to have all kinds of problems later on. We're going to have to cut out welds. There's going to be porosity. So anyways, this is the product form. It's a solid wire. There's nothing in the middle. Later on, we're going to talk about flux cord arc welding, which has a flux on the inside of the wire. But this process, we just use solid wire. So here we're looking at how the process works as far as getting the wire from the spool, our electrode, from the spool through the wire feeder, through the feed rolls, and then the feed rolls are going to push it into the gun liner, which is on the inside of the welding gun, and that wire is going to get pushed down there, and it's going to come out at the end of the welding gun where we're going to run electricity through it. We're going to have some shielding gas for it to keep our weld puddle clean and keep oxygen and nitrogen out of the weld puddle. But if we open up the side of our welding machine, depending on what machines we've got, this is what we can reasonably expect to see. This is an example of a set of feed rolls. This is our wire feed mechanism. This is the little wheels that grab onto the wire and push it down in through the gun liner and deliver it to the contact tip where the electricity is going to flow into the electrode. There's going to be enough current there, electrical current, so then we can melt the filler material and deposit it into the weld joint. I'm going to digress. Not every one of these feed mechanisms is going to look the same. Every company is going to have a different design. More or less they're the same, but there's going to be different ways to open them, close them, little mechanisms on how they, little nuances on how they work. Just like, any automobile you get into, it's got air conditioning and heater and whatnot, but the knobs and buttons are a little different. Every manufacturer of welding machines does it a little different. But generally, we're going to have either 2 of these rolls, feed rolls, or we're going to have 4. We're going to have two little sets of wheels, or we're going to have 4 sets of wheels, depending on the situation. Here is a 4 feed rollers. Just depends on how much money you want to spend and what you're looking for. Like I said, but here's a 4 feed roll setup for the wire feeder. As I explained before, there's different types of feed rolls. Make sure you have the right feed roll for the wire you're using and also for the size of the wire you're using. Aluminum feed rolls are not going to be the same as steel feed rolls. The feed rolls with the little teeth on them we're going to use for flux core. The smooth V groove we're going to use for solid wire. Just make sure that you're using the proper feed rolls for the filler material and the size of filler material you're going to use. One of the consumables that you can reasonably be expected to change out every so often is the gun liner. These are not terribly difficult to change, but there's a little bit to it. You got to take your gun apart, disconnect everything, pull the liner out and put a new one in, and it's time consuming. So even though you do have higher deposition rates with gas metal arc welding, you are going to encounter more maintenance related issues in regards to changing and replacing consumable components on your weld gun, such as your contact tips, diffusers, your gun liner. These kinds of components are going to need to be changed out. Whereas shielded metal arc welding, you don't deal with consumables. You just put an electrode in and weld. It's a coat hanger covered with wood chips and paper. One of the big things that goes wrong with gas metal arc welding and flux cord arc welding is something called bird's nesting. And this is a tangle of wire that happens if your wire feed is not set up correctly. If you got wrong drive roll tension, uh, it can get all snarled up, and you got to stop welding and fix it. So to fix this, you're going to flip up your drive rolls, and then you're going to cut this mess out. You're going to make sure that your wire spool is the spool coming out of the wire. Make sure you've got that secured and wrapped around something. Otherwise, all the wire on your spool is going to come undone, and you're going to have to deal with that. But basically, what you're going to do here is you're just going to open it up, and you're just going to cut it out, and you're going to rethread the wires through the feed roll mechanisms into your gun liner. But yeah, this is nasty. Sometimes you look back and you'll see pictures like this where you just got wire wrapped around everything. But this is called bird's nesting. Very common occurrence. Here's another example. Like I said, it's a tangle of wire, and the wire isn't going to feed in through the gun liner. Welding's going to stop. You're going to be welding, and you're going to wonder what happened. Then you're going to go back and look at your wire feeder and your feed rolls, and there's going to just be a nasty mess, and you're going to have to get some wire cutters out and start chopping and refeed everything, and hopefully you get everything set up correctly so you don't have this issue on a repeated basis. Here's some causes of bird's nesting. If you don't have your wire feed set up correctly, if you don't have the tension settings, if you've got the wrong rollers, if you've got a dirty liner, this can also give you problems. Incorrect tip size can also be a cause of bird's nesting. So when we're fixing a bird's nest, well, first thing we got to do is relieve the drive roll pressure. We're going to untighten that and let that go. And then we're going to basically chop in there and remove that tangled wire. So you're probably going to need a good set of welpers, and there's some pliers that are going to be able to get in there and remove this stuff. Don't damage your feed rolls or go crazy with it. Don't get a big hammer. Just get some pliers, be safe, be nice to your machine, and start cutting away the damaged wire. So then you're going to look at your contact tip. Maybe this is what's causing the problem. Check your liner. Maybe your liner's all gummed up and dirty, and you haven't replaced it in the last 5 years or whatever your time frame is. Maybe your liner is just gummed up in a mess. So after we get that cleared out, and we've looked at our contact tip, and we've looked at our liner, and we've determined they're good, we're going to rethread the electrode wire through there, and then we're going to crank down on our drive roll tension and make sure we've got that dialed in, and then we should be good to go. So in regards to prevention, we need to keep the liners clean. So there's some products that you can use that coming out of the wire spool, you can put these little cloth-like things, and it'll wipe a lot of the crap off your wire, depending on what your wire is, how dirty your wire is, where you're getting your wire. Make sure you got the correct drive rolls for what kind of wire you're pushing. This makes a big difference. Avoid excessive gun cable bends. This is another one. Don't have a really super long gun and then have 52 bends in that thing and have it all wrapped up, because that's putting more stress on the system, more friction. So you're pushing this, you're not pulling it. Pushing is a lot more difficult with wire than pulling. Make sure your contact tip and your wire diameter match up. This can be problematic. So bottom line here, bird nesting is usually going to be a symptom of some other problem. Bird's nesting is not the root problem. You've got something other wrong going on in your system if you've got bird nesting. So you're going to fix this. Like I said, you're going to flip up the drive roll, and you're going to pull the wire back out of the gun. You're going to trim off the affected wire, anything that's messed up. You're going to refeed it through the feeder and back into the gun. As said before, incorrect drive rolls, tension settings, blockages, any kind of crap in the liner. Maybe you might need to replace the liner if your liner isn't trimmed right, too short, too long, pinched, or maybe you've got the wrong liner. You got too small or too large of a liner for your electrode diameter. These can all be sources of bird's nesting. So with MIG gun liners, they're made out of a coiled steel wire, like piano wire. It's going to give it a lot of rigidity and flexibility. And then this is going to allow the wire to be guided through this cable without kinking. So basically, we're pushing wire through a little metal tube, a rigid and flexible metal tube. So this is what we're talking about when we're talking about gun liners. We're just pushing wire through a little metal tube from the wire feeder to the contact tip, where the wire is going to exit the contact tip. We're going to run electric current through it, and it's going to melt and be deposited into our weld joint. So liner problems. So we can have, you know, poor or erratic wire feeding issues, and this is going to give us all kinds of problems, loss of amperage. We can have our contact tip burn back. There's going to be, these can all be signs of liner problems. So this would be an example of, a small wire in a big liner. This can be a problem. This can lead to issues for us. Or, we might have dirty, kinked, or clogged liners because just the length of the contact with the wire, and the nature of welding shops and welding locations, a lot of times our liners can get kinked or clogged. You might have dirty wire too, depending on who you're working for. Some companies don't buy high dollar wire, and they might buy cheap, dirty wire. So this can cause feeding problems. All this dirt and crud can build up in the gun liner and cause your wire not to feed correctly. Even though it's not very expensive to replace a bad liner, it's going to be time consuming, and it's going to take some time to replace, and you're going to have some downtime. So something to think about. Another problem that we can have with gun liners is just depending on the length of your gun liner or your welding gun, sometimes these things can get kinked. Maybe somebody runs over it. Maybe it gets bent in the wrong angle. So a lot of times it'll kink it, and you can see by our depiction here that it's going to impede the flow of wire because we are pushing a wire down a small metal tube, a rigid, flexible metal tube. Any kind of kinking or something happening in there is going to impinge the wire that we're trying to push down that tube. So something to think about. Okay, so this is the nozzle. The problem with the nozzle sometimes is if you don't keep it clean, you're going to not have shielding gas getting to your weld puddle to protect your weld joint from atmospheric gases, not nitrogen and oxygen. So the nozzle is what focuses and sends the flow of shielding gas out to your weld puddle to shield the weld puddle from oxygen and nitrogen. So this is what there's a number of different companies that make welding guns, so each one is going to have differences, but basically the nozzle, you can remove the nozzle and clean it, or you can clean it while it's on the gun. These are a consumable component, so sometimes you're going to have to replace them. So I suppose I should explain what the contact tip does. Well, the contact tip does pretty much what it sounds like. it contacts the wire. So we're running electricity through the contact tip, and it goes from the contact tip into the wire. And it's just done rubbing, touching, whatever it does. So we're transferring that welding current to the wire so then we can melt it. That's the whole mission. So the mission is also we need electrical contact there so that the current can flow. And this helps ensure that we have a stable arc and that, once again, we can melt that wire. So this is the part that is going to take the electricity and transfer it from the welding gun into the wire so that we can melt the wire and deposit it into the weld joint. Okay, this is the contact tip. The contact tip is what the electricity flows through. So the electrical current comes down the gun, goes into our contact tip, contact tube, whatever you want to call it, and electricity flows from that. The electrical current flows from that into our electrode, our welding wire. Contact tips are copper. They are a consumable item. You're going to need a whole little bag of these. Welders will keep bags of these in their little tool kit, in their little toolbox. So when they have to replace these, they've got some. It's important that depending on which wire size you're using, that you have the correct contact tip for the wire size that you're utilizing on whatever components or projects you're working on. Here's a side view of a contact tip. You can see that this one is threaded, and depending on the design of the gun and who makes the welding gun, some are threaded, some are not threaded, but they just thread into the diffuser. Some common problems that we can run into is we're using the wrong tip size, or maybe we're just being complete and utter dirt bags and we're just using our contact tip and we're just chewing it up, just excessive wear. There's going to be a lot of wobble in there or whatever going on. These things don't last forever. They are a consumable. They're like tires. You get a certain amount of miles out of them, and then you got to throw them away and get new ones. Depending on your settings and what you got going on, you could have spatter buildup in there, or you could have burn back damage. Sometimes you just got to throw these things away. You got to throw them away anyways because they're a consumable. You only get a certain amount of mileage out of them. This is the diffuser. So the shielding gas is going to flow down our welding gun, and it's going to flow out those little holes on the side of the diffuser, and then our nozzle is going to direct that shielding gas to the weld puddle. It's going to surround our wire, and it's going to surround the shielding gas is going to surround our wire and our contact tip, and our shielding gas is going to flow out the end of the nozzle. Questions, comments, thoughts, concerns? Gary A. Pace, PE, welding engineer, Katy, Texas.